Hello and a warm welcome to this webinar on transforming test data management with copy data virtualization organized by Maverick Systems. My name is Edwin Richard and I will be the moderator for today's session. All attendees have been put on listen only mode. You may raise your questions using the chat window. All questions will be addressed at the end of the presentation. Before we begin, let me introduce you to the speakers for today's session, Mr. Lakshmi Narasimhan and Mr. Tirunavukarasu. Mr. Lakshmi Narasimhan is a Vice President in Product Engineering at Maverick Systems. He has over 24 years of experience across 15 years in fintech, delivering platforms and systems in capital markets, payments, and investment banking domains, and 7 years in mission critical and embedded computing. At Maverick, Lakshmi Narasimhan plays a key role in implementing and supporting platforms and technologies in test design and execution, automation, and lifecycle management. He provides direction and support to teams implementing automation strategies in test design, automation, and test lifecycle management. Our other presenter is Mr. Tirunavukarasu. He is a senior manager in integrated delivery at Maverick Systems. Tirunavukarasu is the data management professional with over 15 years of experience in manufacturing and financial services domain, with extensive experience in developing data quality solutions. He has also worked in areas of data modeling, data analysis, and data programming, and he has explored and has a very vast knowledge about test data management. Now, I would like to have Tirunavukarasu to take over and get started with his presentation. Over to you, Thiru.
Thanks, Edwin. Welcome, everyone. Okay, so today we would like to give a brief intro or have a discussion regarding how we can transform test data management with copy data virtualization. Basically, we will be talking about two topics here, mainly how we can do copy data virtualization, and the second part is like talking about TDM and then how CDV is used in TDM. So before I move on to the topics, I'll first tell you the brief agenda of what we are going to discuss. So mainly the topics are going to be copy data virtualization and test data management. So in the copy data virtualization, we will be talking about what are all the challenges, very generic challenges that are faced by the industry in managing the copy data, and then when the copy data virtualization is implemented using the tools available in the market, how the tools works, and then we will be talking about one of the case study, like what challenges our customer faced and how we had overcome with one of a CDV tool. And then we are going to talk about test data management. In that, we will be briefly talking about why we need a TDM, and in TDM, what are all the areas generally we should be focusing, and then finally a generic solution, which is a tool agnostic, like using how we can define a TDM using data masking, synthetic data generation, and then provisioning the data using copy data virtualization method. Okay, so if you see the challenges, generally the copy data is like 5 or 6 fold of what the actual production data is. So what we mean by copy data is, assuming I have a production data, I may need to copy the data for multiple purpose, like taking it for backup or for a disaster recovery or for a reporting. And then now more than that, the main purpose is test data. Mainly this is for a development environment where they want to do their unit testing, and then development testing area where they may be doing a QA testing, SIT and performance testing, and also the UAT. So we will be copying the data into multiple environment and using it. So there are a lot of challenges faced by the companies when they are having enormous amount of data and enormous number of copy data requirements. Like we have listed out a few areas. Generally, there are about 200 data sources which are used by more or less all the organizations, and each data source is copied at least 8 to 10 times for a testing purpose, either being a dev testing or QA testing or UAT, whatever it may be. So, and it seems like they will be refreshing the data at least once in a day, once in a week. So that means the companies are going to refresh about 2000 copies every week. And assuming that it is taking half a day, we can say roughly say that every week they are spending about 1000 man days just to maintain their copy data, and especially related to testing purpose. So this is a very huge effort and requires a lot of hardware, storage. It's a huge overhead on the organizations. And due to all those additional effort, there are about 85% of projects delayed because the testing would not proceed because they need to wait for the data to be available for their testing to be executed and completed. That's a huge challenge. In fact, I will show some of the real-time experience of what we had seen in one of our client place, which I will be explaining in our case study. And if you see, as per the survey, the business volume is about 48 billion, which is actually eightfold of what we are talking about, the big hangama about Hadoop, because Hadoop's business volume is about 6 billion per year worldwide. But this we are actually not talking, but the data, the business, this copy data costs business about 48 billion. So it's a huge thing that needs to be addressed at the earliest. So let us see how the CDV works. Okay, so this is the typical thing we will be having. Like we have a source database here. When I say source, it may be a actual production data copy data or even a copy of the production data which needs to be copied into the applications. So generally what we do, assuming I have 4 applications requires 4 different data source, we will be copying the source 4 times and then provisioning it in the test environment the same data. We may either provision the same data or we may do subsetting or anything which based on the requirement we will do. So that's the challenge we are talking here, like why we should need to keep 4 different physical copies, whereas with the CDV tool, we don't need to maintain all but only one. So let me see how the CDV works here. So once I have a CDV tool, the first thing is it will take the initial dump. And one of the key factors of using a CDV tool, it will not just replicate the actual source data. What I mean source is, for example, assuming I have an Oracle database, and the size of the database is about 5 TB. But when the data blocks are copied into CTV tool, it will be generally 40% less than the actual size, mainly because when the data blocks are copied, it will not copy the duplicates, because generally the RDBMS tools keeps duplicates to ensure if some system in a cluster environment, if some system goes down, the data copy will be available to ensure data is always online. But since this we are taking it for a copy purpose, they don't need the duplicate data to be available. So they ensure the data is deduped, and also they compress the data when they store it internally within their tool. So it is roughly 40% less than what the actual size of the tool. What's the actual size of the source data. So once this initial set is taken, now the data is available for provisioning. So what it does, it just creates a virtual pointer which the applications can start using now. As you can see, it is not going to duplicate it. So the data provisioning can be done within a minute, because it's not actually creating any physical copy. It's just creating a pointer which the applications can use, and from an application point of view, it will look like a physical copy. And apart from initial load, we can also define our SLAs for an incremental data update. When I say SLA, it can be like, okay, I want to refresh the data every 1 minute or 1 second, or even it can be hours or days. Based on the requirement, we can do the incremental load. And one of the key factor here is, during incremental load, it will not update the initial data set. Also, it is not going to take every information from the source database. It will only take the blocks which are changed from the initial version or the previous version, I would say, because when we are having multiple incremental loads, like after T1, when the T2 comes, it will actually take changes which happened after T1. So this way, you will always have one initial full set and the incremental changes. Now, when you want to have a new version of the current data block, how the tool will do is, it will take all the blocks from CTV, the initial data block set, as well as it will take the data block set from T1 where only the changes are there. Now, if any block is updated in the initial set, it will ignore that data set and it will take the T1 data set. So this way, you can say whatever data needs to be provisioned, it just creates a pointer and provision it. So no additional data set needs to be copied for every application. And even you can create a virtual copy for a previous tool set. It's not like once a new T1 increment is available, you cannot take the provision the data for provision the data of old set. You can provision the data set of any timestamp, like T2, Tn. We can, based on the requirement, we can make all the provision all the data set available based on the requirement. Now the important question is, all these are virtual pointers only. So if application is trying to make a change, how that will be stored? Because if it is updated by in the main copy, then the main copy will be available, visible to all the other applications. So that means other applications will be impacted. But that is not what we want. So how the tool works, when you are making a change, when an application makes a change, it only the changes are stored in a separate local copy, and the pointer now points to the changes. So that application alone will now see the change, whereas the other applications will still see the actual data that is provisioned to them, and they are free to change whatever data they want. And whenever they made a change, like the blue circle, blue block created for the second application, a additional local copy will be created for each application. So this is the way the CDV works. So as you can see, you don't need to deploy multiple data sets for each environment. So you are reducing a big amount of storage as well as hardware. Also, even the actual data is deduped and compressed. So you don't end up having a big storage space separately for CDV tool. It will be much lesser than the actual source data itself. So those are all the big factors of using CDV. Now let's see how the case study of how we had used a CDV tool in one of our client. So the client is based out of UK, and they are mainly a leading outsourcer and technology solution in the financial sector. So they had a challenge. The challenge is they have about 40 plus test environments for dev and QA and UAT, and they do 20 at least 20 deployments per week, and they are actually each deployment takes about 3 hours for them. And mainly if the problem, the challenge is the reason they are having 40 plus environment is, though they are using the same data set for all environments, they need to copy it into 40 plus environments to ensure one tester, if a tester changes a data in one environment, it shouldn't be impacting that testing happening in other environments. So to ensure that, they end up creating more and more test environments, and before we actually went in, they had about 40 plus test environments, and they have been provisioning the data physically in those 40 plus environments. So we suggested them to use a CDV tool, and currently they have been using it, and the benefits are they now don't need separate storage hardware and storage for those 40 environments. So that resulted in about 50 to 70% of hardware and storage reduction. And also, instead of spending about 60 hours per week for deployment, now they can do all within an hour. So that is more than 90% of savings in their effort. And overall, in their budget, it's a saving of 56,000 pounds on a year-on-year basis. So that's a huge benefit for them, because this 56,000 pounds is after considering the investment they have been doing for purchasing a CDV tool and a CDV appliance required for that. So they even after all those things, within 3 years, they can get 56,000 pounds on a yearly basis. So that's a huge improvement of using CDV compared to actual data provisioning, physical provisioning. So now let us see how this CDV can be used in a TDM. So before moving on to how CDV is used in a TDM, we just want to see what are all the different important things to consider in TDM, and especially why we need a TDM. So when we say why, there are four main areas which we think that demands a test data management. One is the current way of working, the distributed environment. Like in a current scenario, we have a system where people are working from different places. Like development is happening in one area, and testing is happening in another place, whereas actual data deployment is happening in different location. So we have such a distributed environment, and data needs to be moved from one location to another location, and the problem is the volume of data and the sensitiveness of data, because when the data moves out of the organization, it has to be sure, we need to be very sure that no sensitive data goes out of it. So that's a huge challenge in a distributed environment. And also currently we are working on an agile way of working, and agile and DevOps are the key things happening in the IT industry now. So time to market is the key factor. So we need to be very sure that the whatever the changes happening in a week or two, couple of weeks time, that changes are tested properly and goes to market without waiting for the data to be available to them. So that requires data to be available always, and whenever a tester requires, they should be able to provision it either by themselves or even with a team which involves, but they should be able to provision at the earliest. And the other key area is the data complexity, because now we moved from a long way of from legacy to current systems, But even lot of organizations, especially in the banking area, still uses legacy systems, either it being a mainframe system or a tandem. And even if it is a modern way, they may have an Oracle server, SQL server, Teradata, Hadoop. So we have data scattered across multiple places, multiple environments, and multiple databases. The huge challenge is when a new application is introduced, the data needs to be actually procured from multiple source systems where they are coming from. For example, we may need to take data from a tandem application and a SQL server, which may be actually used for analytical reporting. So if I need to test that analytical reporting application, I need to first get the synchronized data from two different environments and ensure the data is available in a proper format. So that data complexity is a huge demand which requires TDM. And the next thing is mainly related to what we do, how we do the testing. Because for a developer, when they do unit testing, the way they do testing, unit testing is entirely different from how the QA testing happens, how SIT happens, how UAT or performance testing happens. Because if I am doing a performance testing, I am not bothered about the functionality of the data, but I am very much interested in having a huge volume of data available so that I can see whether the application is able to handle that huge volume and whether it can even I can see whether the stress on the database as well as at the application level with a huge volume. Whereas if I am doing a UAT, I need a very minimal data set, but at the same time I need to ensure that the data coverage is there, because when they do UAT they will be testing for all the business scenarios. So if a data is not available when for a business scenario, they will not be able to test. They don't bother about volume, they bother about the availability of a specific test data. So the requirements changes for different types of testing. So we need to ensure for every for a different purpose of testing, the different requirement will be there and how the data can be available for that requirement. So that's one of the requirement for test data management. And the last but not least, the data security, because that is the very key factor, though we actually mentioned as the last one. That is the primary reason we should go for TDM, because as we talked about in the first three sections, whether it is due to distributed environment or complexity or type of testing, whatever data is visible to the tester, we need to ensure the data is insensitive. They shouldn't be seeing any sensitive information or a confidential information of a customer when they get the data for testing. That's going to be a huge challenge, because generally what we do, we take the data from production. Either we may give provision the full data set, or then we may do some subsetting and then provision it. That is not a critical part, but the critical part is how we are going to ensure the sensitive data information is cleansed and provisioned it. So generally what people do is they use some custom scripts to just remove those sensitive information and provision it. But the problem is when they remove, the business logics they will lose the business logic, and the data available to the tester may not be meaningful. So it is very critical that we remove the sensitivity of the data without losing the business nature of the data. So these are all the four areas that demands TDM. So that's the reason we now focusing, actually not just four, there are five areas that we are focusing when TDM is implemented. The first is, as we talked about, the prime critical one, which is sensitiveness. So we need to ensure the data is properly masked, and there are different methods available like lookup, scrambling, shuffling, all those things. And as I told, the important thing is when we use tools available in the market, they use these techniques to ensure the sensitiveness of the data is taken out, but at the same time, the business nature of the data is retained, because we are either using some scrambling method or lookup method to replace with the non-sensitive information, but other informations can be retained. So this is related to data masking. The other thing, as I told, data coverage. So when you are taking data from production, you may not have coverage of all kinds of testing, especially if you are doing a negative test cases. The production data may not be having that negative data. Also, if you are doing some enhancement, or even if you are creating a new application, you may not have the data required for your testing if you just rely on a production data. So here the synthetic data comes in. Basically, there are tools available in the market which can actually generate the data in the format required, and you will actually will not realize that the data generated is a generated data. It will almost look like how the data looks in a production system. So data masking, data manufacturing. Now we have the data available in a central place. Generally, we keep it in a place called cold copy, and then the data is now available for provisioning. So before provisioning, there are a lot of places where they need a data subsetting to be done, because it is not always required to provision the entire data set to a test environment. They may need probably some 6 months of data, or they may say I need a 5,000 customers data, or even they may do some sub vertical level. For example, if I am having my core banking data, for some testing I may only need customer data, or I may only need credit card information or loan information. So they don't need the entire data to be available when they are testing a specific business region. So that in that place, we will be doing the data subset before actually provisioning the data in the test environment. So the next step is, now I have the data masked, and also I ensure data coverage is there with the synthetic data. And now I also ensure data is subset based on the business requirement. Now it is ready for data deployment. And this is the place where the CDV comes in picture. Basically, wherever the data needs to be provisioned, we can just use the CDV tool to provision the data without actually deploying the data. By just virtually deploying, we can provision it in minutes, and the user now have n number of test environments. Even we can provision one test environment per user, per tester, and they will be able to test the data without impacting others. And the last segment in this focus area is data management. This is critical because now we talked about the technical factors of a TDM like data masking, data manufacturing, subset, and deployment. But the data management is a non-technical, I mean non-functional, but it's a key factor in provisioning the data, because you need to have a proper management of test data so that it will be easier for the testers to provision the data. So we should be able to have some provision available to configure the subset requirements, and we need to know, if I have to do the data masking, we need to know how to configure how to identify a sensitive data. So that means we need to define the data patterns for identifying. And also, if I have to do some data manufacturing has to be done, I need to know what are all the business rules so that we can create data which will satisfy the business rule. So all those require some web UI or a format through which we can manage the data. So these are all the 5 focus areas when a TDM is implemented for an organization. So now we had seen why we need a TDM and what are all the focus areas. So now we are going to explain a generic solution, like I have a source system and what are all the steps I will be doing before I actually provision a test data to a application. So let's start with a source database. Now we have multiple databases available, and my requirement is how I am going to provision this data by ensuring the sensitive information is masked, and whatever data coverage is maintained by creating synthetic data, and then finally data is provisioned using a copy data virtualization tool. So before we do anything related to data masking or anything, the first step is defining the access control on the source database. Generally, that will be defined at the organization level, but it should be also defined at the TDM level to ensure what access control should be defined for each source system and for each user. Now that is defined, and on top of that, the first step is data discovery. So here when we say data discovery, it's basically doing two things. One is data profiling, and then the second is sensitive data discovery. So why we do data profiling is in lot of systems, especially if your source is a legacy system, you may not have the data relationships defined in the database level itself. Even if the data is stored in RDBMS, generally if you are using some applications, the data constraints are defined at the application level. So when we go through our database, the data relationship may not be available in the data itself. So which requires data profiling, and through that we can identify how data is used, how the relationships are identified, and then we can review that with the SMEs to define the relationship between the data. And even especially this will be very critical if you are actually sourcing data from multiple databases, because you will never get relation between multiple databases. So in this phase we do that part, identifying data relationship. And the second part is sensitive data discovery. So how sensitive data discovery is done is we define the patterns. The pattern can be based on the column name, or it can be based on the actual data itself. So for example, if I am searching for a credit card number, my data pattern would be like I will be searching few things like column name like credit card or credit underscore card or something. And also I will check by data and I will see whether the data is 16 digit or not, or if they have stored with hyphen, then whether it is four numbers hyphen four numbers. So I can define a format required for the data to be searched, and then we can run the tool on the production data or DR to see which are all the columns are sensitive data. So those are all the two things that we do in data discovery. And then with that information, we do the data classification. So in that place, we define what are all the sensitive data, and even you can define business level grouping, like these tables are belonging to credit card, these data are belonging to loan LOS, something like that. We can do the classification, which we will be mainly using in the subsequent task. So now we know what are all sensitive columns. So the next step is masking. So here again the tools can be used. So the tools can deploy different types of masking technique, like lookup or scrambling. Even you can define our own user defined masking techniques to mask the data in the way we require. So now it's time to create the gold copy and store the data, because I had taken the data from source systems, now masked. So this data is now ready to provision to test environment because I have removed all the sensitiveness of the data. Okay, but as we talked about, we do not we do not know whether sufficient data coverage is there with the data copied from production. So in this place, we also bring in the synthetic data generation. The tools available in the market can be used to configure the business rules and how the data should look like, and we can generate the data required. So the general idea is whatever the data masked from production as well as the data generated should be stored in gold copy, because that is going to be the source now when you consider from the data provisioning perspective. This will be the one superset of data and which can be used for subsetting and everything. Okay, now we have defined the data masking and synthetic data generation. The next main important thing is data management, because you need to have that information stored in somewhere so that this can be repeated. Otherwise, everything you are doing is going to be a one time. So whenever you do the data discovery or data classification, it should be stored in the metadata, and all your masking rules should be stored in some repository. Similarly, your provisioning rules, subsetting rules, and synthetic rules. Okay, now we have the data management available, and we also masked data with the synthetic data generated. Now it's time to do the data provisioning. So during provisioning only, we will also ensure the data is subsetted before it is actually provisioned to the test environment. So during provisioning, we may do two types of provisioning. One is what we discussed, the copy data virtualization method. So in that case, you are not actually going to create n number of physical copies. You are just going to point your CDV tool on a gold copy, and it can actually create whatever number of virtual databases required for you. It can create, and your applications can point to that. Or in some cases, you may need a physical copy itself. It is based on your requirement. For example, generally organizations prefer a physical copy for a performance testing. So in that case, we don't need to use the CDV, or even we can use the CDV to create a physical copy, because the tools available in the market has both options. You can either create a virtual copy, or you can actually clone your source and create a physical copy. So this is a generic TDM solution, and this is not specific to any tool, because there are n number of tools available in the market, and each has its own plus or minus, and so that's the reason we haven't used any tools here. We just wanted to give a brief intro of how TDM works and how we can use CDV when a TDM solution is implemented. And I will now hand it over to Edwin.
Hope so the session was informative, and it gave you a fair idea about how copy data virtualization is starting to play a key role and in the test data management implementation. And thank you, Thiru, for the informative session. And thank you guys for attending this webinar.